Welcome, geometry students. Today we're taking a look at the review worksheet for the Chapter 3 test. So let's start with problem number 1. Looking in problem number 1 at finding the value of x and y. First thing I recognize is that the 48-degree angle and angle y, I shouldn't put single arc marks around both of them, those two angles are consecutive interior angles. And consecutive interior angles when the lines are parallel have to be supplementary. So I would start with 48 plus y has to equal 180. And if I take 180 and I subtract my 48 to get my y value, I should be left with a y value of 132. Okay, something else I recognize is that the 48 degrees and the 5x minus 17, those are alternate interior angles, and alternate interior angles are congruent if the lines are parallel. So 48 would have to equal 5x minus 17. If you add on 17 to both sides, you should end up with 65 is equal to 5x. Divide both sides by 5. And we are left with the x value of 13. And that completes part A. Part B, I look at the 2y and the 58 in the diagram. Those are corresponding angles. And if the lines are parallel, corresponding angles are congruent. So I can set 2y equal to 58, divide both sides by 2, and I get y equals 29. The next thing I notice is that the angle labeled as 2x and the 58 form a linear pair, and linear pair angles are supplementary. So to solve for x, I can add those two angles together, 2x and 58, and it should give me a grand total of 180. Solving for x there, I can take away 58 from both sides, and I'm left with 2x is equal to 122. Divide both sides by 2 to get my value for x, which looks like it's going to be equal to 61. There we go with problem number 1. Moving forward to problem number 2. In problem number 2, it says when two lines are cut by a transversal, and those two lines are parallel lines, name the angles that are congruent. There are actually 3 pairs of angles that are congruent. They are the corresponding angles. There are also the alternate interior angles. And finally, they are the alternate exterior angles. When two lines are parallel lines and they're cut by a transversal, what kind of angles are going to be guaranteed to be supplementary? Well, there's one pair of angles that are meant to be supplementary, and those are the consecutive interior angles. And that takes care of question 2 and 3. On to question number 4. Question number 4 says, can you find the value of x that makes our two lines parallel? So if we're going to make our two lines parallel, we've got to go back and work with the kinds of angles that we said were congruent or supplementary. So if I look at the 147 and the x plus 14 in my diagram, those two angles look like they're in positions for alternate exterior. And there's a converse theorem that says if alternate exterior angles are congruent, then the lines are going to be parallel. That's your alternate exterior angle converse theorem. So let's set them equal. 147 is equal to x plus 14. We subtract 14 from both sides. and we're left with 133 is equal to x. I move over to my second diagram and just trying to help you out here. I know that that interior angle that has a little green mark to it is what 2x plus 20 is set equal to. That's where the 2x plus 20 is located. And we've got our 3x in this lower direction on the outside. It's an exterior angle. Well, one thing that I can do with that 3x is that I can work with, I'll use double arc marks here, that angle of 3x can get carried over as a vertical angle to become an interior angle. Well, that interior angle that I just marked and the green angle that represents 2x plus 20 are consecutive interior angles, and consecutive interior angles are supplementary when the lines are parallel. So if I want to make M and N parallel, I've got to make my 3x and my 2x plus 20 supplementary. So we're going to add 3x to 2x plus 20 to get that grand total of 180. So I can simplify here and get 5x plus 20 equals 180. Subtract 20. 5x is equal to 160. Divide both sides by 5 to finish off solving for x. And I get an x value of 32. So if you let x equal 32, then you have consecutive interior angles being supplementary. And as long as they're supplementary, it forces the lines to be parallel. And this would be by the consecutive interior angles converse theorem. So good theorems to be paying attention to. So we bump forward to question number 5. Question number 5 says, write the equation of a line that passes through the given point and is parallel to the given line. So we've got two problems where we're going to work with coming up with parallel lines. So what we're going to do here is the first thing, I'm going to take the equation that was given to me, and it's nicely written in slope-intercept form. Remember, the slope-intercept form is y equals mx plus b. And with it written in that form, I should be able to just pull out my slope by looking for the number in front of x. Now, all I really see is a negative sign, but I could tuck in this 1 in between the negative sign and the x and say that the slope is really a negative 1. So I'm working with that slope of negative 1, and I'm working with the ordered pair 3, negative 4. That's my x sub 1 and y sub 1 values. And if I'm going to come up with an equation for a line, I'm going to start by putting this information in point slope form. And then I'm going to change it into slope intercept form, which is what we see right there. So I've got 3 substitutions to make into this equation right here. I'm going to plug in a value for y sub 1, for m, and for x sub 1. So starting over on the left side, y minus my y sub 1 value would be the negative 4. Well, if I'm subtracting a negative 4, that's the same as adding on positive 4. I then put my equal sign down, and in for slope, I put my negative 1. That was the value I found over here. And then in parentheses, x minus my x value of 3. Okay, perfect. This is point slope form. It looks great, but we need to change it. We're going to practice changing it into our slope intercept form. In order to do that, we're going to carry that negative 1 through the parentheses. So we're going to leave y plus 4 alone. Negative 1 times x gives us negative 1x. And finally, negative 1 times negative 3 gives us positive 3. Last step to get it into slope-intercept form, subtract 4 from both sides. And here is our final answer. Y equals negative 1x. You could just write that as negative x. That's fine. And then 3 minus 4 leaves us with a negative 1. There is our slope-intercept form for a line parallel to the given line going through point A. Let's try that one more time with part B. In part B, Our equation is in standard form to begin with, but I don't know what the slope is when it's in standard form, so I need to change it again into slope-intercept form. I need to solve it for y, and I can do that by adding on 3x to both sides. So if I do that, I'm left with y equals, I'm going to put my x term first, which is a positive 3x minus 5. Now, when the equation's in this form, I should be able to pull out what the slope is. The number in front of x should be my slope. That's the 3. I'm going to use that and my ordered pair x sub 1, y sub 1 to come up with point slope form. And then I'm going to change it into slope intercept form again. So I'm going to start with this form. That's my point slope form. I'm going to make 3 substitutions in. Y minus my y sub 1 value is 0 is equal to, my slope was 3, in parentheses, x minus x sub 1. X sub 1 value was 2 from up above. Okay, I'm going to multiply the 3 through. 3 times x is 3x. 3 times negative 2 is negative 6. Well, y minus 0, I'm not sure why I've kept that minus 0. I don't need to keep it there. I can say this is going to be my final answer. I don't even have to move anything over because minus 0 doesn't do anything. It just really has the value of y. Y equals 3x minus 6. That is the equation of my parallel line to the original given line going through the point 2, 0. Okay, moving forward to the next question. Let's see if we can keep our process going here. Number 6 says we're going to write equations to lines that pass through the given point but are perpendicular to the given line. So perpendicular means that not only do you need to find the slope from the given line, but you need to work with opposite reciprocals. So I'm going to highlight that where you got to look for opposite reciprocal. This is an added on step because in the previous problem when we were looking for slope, parallel lines have equal slopes. We didn't have to do anything above and beyond. But here, when I find the slope is negative 2, I need to find the opposite reciprocal of negative 2. So it might help by putting the negative 2 over a 1 so that you can think about it as a fraction. So over here, I'm going to stress that I'm finding a perpendicular slope. So opposite means opposite in sign. If the original slope is negative, then our perpendicular slope is going to be positive. So we don't have to worry about a negative sign. And then reciprocal means switch your numerator and denominator around, which should give us a 1/2. We still have our x sub 1, y sub 1 values. We're going to plug all that information into point slope form. And then from point slope form, we're going to change it into slope intercept form. So 3 substitutions. Y, and if I subtract my negative 1, subtracting a negative is the same as adding. So plus 1. My slope of 1/2 comes in. X minus my x sub 1 value is 6. 2 steps left. We're going to distribute the 1/2 through the parentheses. So y plus 1 equals 1/2 x. 1/2 times a negative 6 is negative 3. And we subtract 1. So my final answer here, if I move that plus 1 over to the other side, y equals 1/2 x minus 4. 1/2 x minus 4. Okay, let's tackle it again in part B. We have an ordered pair, 8, 2. That's our x sub 1, y sub 1 ordered pair. And our problem with our equation, it's in standard form here, but we need to change it into slope-intercept form so we can find the slope, which means we need to get that x term over to the other side because y needs to be by itself. So let's add on 4x to both sides. So we should be left with y equals 4x minus 7. The number in front of x should be your slope. I'm going to make it as a fraction so that it's helpful to get a perpendicular slope, opposite reciprocal. So notice our 4 over 1 was positive, so its perpendicular slope would have to be negative, opposite in sign. And we need to switch the 4 and the 1 around, so we get 1/4. So if we look at putting it into point slope form and then changing it into slope intercept form, there's our point slope form. Let's make 3 substitutions. Y minus our y sub 1 value is 2 is equal to, put your slope of negative 1/4 in, and then x minus x sub 1. We're going to distribute that negative 1/4 through. That doesn't touch the y minus 2. On the right-hand side, we get negative 1/4 x. Negative 1/4 times negative 8 is going to be a positive 2. And our very last step to get to our last answer here, let's add on 2 to both sides. And we get a final answer of y equals negative 1/4 x plus 4. Okay, that's a lot of writing equations. Now let's see if we can tackle some problems that don't take quite as much thinking. So question number 7. Determine whether the lines are parallel, perpendicular, coinciding, or intersecting. So parallel means that the slopes are going to be the same. Perpendicular, the slopes are going to be opposite reciprocals. Coinciding, that's when the lines are exactly the same. So they have equal slopes and equal y-intercepts. And intersecting lines, if we're going to say they're intersecting, then that's kind of the none of the above. It's something other than the parallel, perpendicular, or coinciding. Okay, so I look at my first equation and I pull out my slope. It's going to be that number in front of x. There's the slope of my first line. For my second equation, it's not quite solved for y, but if I could get it solved for y, if I can get it in that form, y equals mx plus b, I should be able to pull out my slope, the number in front of x. So let's divide everything by 3. It might help to put a 1 in front of that x. So we get y equals 1/3 x minus 6. The number in front of x is 1/3. So I recognize that my slopes are the same here. The other thing that I double check is that they have different y-intercepts. So they're not coinciding, they're just parallel. So only equal slopes. Perfect for that. So check off number 7. We're making it here, one thing at a time. Number 8, same kind of question. Determine whether these lines are parallel, perpendicular, coinciding, or plain old intersecting lines. Ooh, they go to our special kinds of lines, and we've talked about this in class. If x is the only variable that you have in the equation, this equation, and any equation that just uses an x, should be the equation for a vertical line. So that's a vertical line equation. And then I move over to the right-hand equation. And on the right-hand side, I see y equals a number, only the variable y. And when I see only the variable y, I think about another special kind of line. And that kind of line is a horizontal line. All horizontal line equations only have the variable y in them. There are no x's. And if I look at these two equations and think about, what do I know about every vertical line hooking up with a horizontal line? We learned something in section 3.5 that said that a vertical line and a horizontal line, any vertical line and any horizontal line are going to be perpendicular to each other. So perpendicular. is our final answer for number 8. Okay, let's move forward to question number 9. Question number 9. In question number 9, it's determine which lines, if any, must be parallel. Explain your reasoning. So if we have some theorems or something written on the diagram that can help us to give an explanation, we want to use that. So first thing I do is I take the information that's provided on the diagram. I'm going to take these right angle symbols and I'm going to use them to make perpendicular statements. So the one on the left would mean that line Z is going to be perpendicular to line X. The second perpendicular right angle symbol is going to tell me that line Y is perpendicular to line Z. And what this tells me, because this line Z is overlapping between the two statements, if line Z is perpendicular to two other lines, then those two other lines are actually going to be parallel to one another. So I can bring X and Y together and say that X and Y are going to be parallel to one another. We have a theorem that says exactly that. If two lines are perpendicular to the same line, then they're parallel to one another, and that is because of the lines perpendicular to a transversal theorem. Let's see if we can try that same kind of theorem over here. I'm going to start with the left-hand side. The two lines that come together to form that right angle would be line Y is perpendicular to line W. Go to the right-hand side right angle symbol, and that connects line Z to line X. Okay, so maybe I'm a little disappointed because when I look at those two perpendicular statements, I don't see the overlapping that I saw in part A. And since no line is included in those two statements, I don't have the ability to say that I have any parallel lines. So no parallel lines. There's no parallel lines guaranteed here. Okay, that would be number 9. So let's keep moving forward from there. Okay, number 10. Number 10, I have a little bit highlighted already on my diagram. I circled point Q. This is kind of the way the quiz was set up as well. Keep in mind that point Q is the point that has to be included in every one of your answers. So think of each statement in the diagram as a part of a line. Which line or lines or planes containing point Q would appear to fit the description. So skew to line NP. So here's NP. If it's going to be skew to this line, that means that it's going to never intersect with line NP, but it also is not in the same plane as NP. So it's got to contain point Q. The only one that we can come up with there is if we go straight up and down and do this. This is the only possibility, and that would be line QL. Let's make sure we use the right line notation. Every one of these answers should use the point Q. Perpendicular. We want perpendicular to line NP. Well, perpendicular means it needs to form a right angle. Look, you can see those right angle symbols along the bottom of this box. You got to go in this direction to get perpendicular. That would be line QP. Part C. Ooh, the plane parallel to plane JMR. So JMR is the front plane. It's this. If I want it to be parallel, it has to be non-intersecting with that plane, and actually you have a lot of planes that intersect with that plane for the box that's been formed there, but the one that won't, that contains point Q, would be the back of the box. We got to name it by 3 letters and start with the word plane in front of it. And 3 letters, I'm going to include Q since it's got to include the Q. I could include L and K. If you wanted to include one other letter, P would be the other option. You can only use 3, but you can use any of these 3. The P would be the 4th option. that would be possible. Then you'd have to exclude another one of those letters. Okay, finally, we want parallel to NP. So parallel means that it's in the same plane as NP, as that line, but it's not going to intersect, and that would be on the right-hand side of the box. It would be this bottom line, which would be line QR. Again, line notation, don't forget that line notation, and check that off the list. Okay, oh, it's two-column proof time, but I have some hints in here. We've got this. In the diagram, R and S are parallel to one another, and angle 1 is congruent to angle 3. So let's put some arc marks for angle 1 and angle 3. So we want to prove that we have parallel lines in the other direction, that P and Q are going to be parallel. So step 1, well, that's going to be your given. Let's put down R is parallel to S, and angle 1 is congruent to angle 3 by given. Well, if R is parallel to S, I can come up with another congruent statement. I can say that angle 1 and angle 2 are congruent. I can say those are congruent. And they are congruent because if R and S are parallel, 1 and 2 are corresponding angles if you think about line Q as being the transversal. So we call this corresponding angles. Angles congruence theorem. It's not the converse, it's just the corresponding angles congruence theorem. Okay, let's see what step 3 has us doing. Ooh, they want us to use the transitive property. I'm going to take an educated guess that we need to use that statement and push them together to apply the transitive property to make a statement about congruent angles. Well, what's overlapping between these two congruent statements? It's angle 1. So angle 1 should be able to be eliminated from the congruent statement, and you should be left with the other two. So angle 2 should be congruent to angle 3. Well, this should be our last step, so we should be down to what we need to prove. But look at, if angle 2 and angle 3 are congruent, those are corresponding angles for lines P and Q if R is a transversal. And we have a theorem that says if corresponding angles are congruent, the lines have to be parallel. That's a converse theorem. So our final step, line P and Q are going to be parallel, and we're working with almost the same theorem as number 2, but it's the converse portion of it, corresponding angles converse theorem. If corresponding angles are congruent, then the lines that form those corresponding angles have to be parallel. Okay, check that off. Whoops, let's get to the right slide here. And this should be our final slide. Write an equation for a line that passes through 1, 5 and is parallel to the line y equals 2x plus 3. Now, we've done a little bit of this already, but let's go back and practice it one last time. We're really just trying to stress the importance of these problems, and I'm just going back and double checking that we're not doing a duplicate of what we've already seen. Nope, these are different. So remember, if it's going to be parallel, we want the same slope, so I can pull the slope out of the line that was given to me. That would be 2. Remember, the number out in front of x is your slope. Use this as my x sub 1, y sub 1 value. And let's put it into point slope form and then change it to slope intercept form. So close to the end here, just a little bit to go. So make 3 substitutions. Y minus 5 is equal to 2 times x. Oh, the x sub 1 value is negative, so minus negative makes plus. Got it in point slope form. We're going to distribute the 2 through. Y minus 5 is equal to 2x plus 2. Make sure both the x and the 1 get multiplied by 2. And finish it off by adding on 5 to both sides. Y is equal to 2x plus 7. There is your equation for a line parallel to the given line that contains the point -1, 5. And finally, look at this last one. There's a line also in slope-intercept form, but this time I want a line perpendicular to this line. So when I look at this slope and know that the slope is 4, I can call it 4 over 1. I'm going to work with the perpendicular slope, which should be the opposite reciprocal. So if 4 over 1 is positive, the perpendicular slope has to be negative. Then you need to switch the numerator and denominator around. And now you have to use the point to make that x sub 1, y sub 1. Use that ordered pair. We're going to start with point slope form. We're going to change it into slope intercept form. Make your 3 substitutions. So y minus a -1, which is going to be y plus 1. Slope is -1/4. X minus a -4 becomes x plus 4. Two things. We got to distribute that -1/4 through, and then we're going to get rid of the plus 1 on the left side. -1/4 times x is -1/4 x. -1/4 times 4 is -1. Finish off by taking away 1 from both sides so that it's solved for y. Y equals -1/4 x minus 2. There is our equation. And that concludes the review worksheet. Thank you so much for listening, and please don't hesitate to ask questions. Have a great day.